next speaker who will be talking on a very hot topic, 5G. Just now, MOS has also touched on this topic. Our next speaker, Glenn Vandevoorde, CEO of Akana Technologies, will talk about cases of usage of 5G applications that will change our lives and businesses. And he will go through the driving requirements for semiconductor companies to build the new 5G infrastructure. Glenn, over to you on the topic 5G, building the infrastructure that will accelerate the global economic recovery. Glenn, please.
Okay, thank you, Jillian. Just give me a second to share my screen here.
Sure.
Yeah.
Glenn, and you have to turn on your video so that we can see your face.
Yeah, sure. Hold on.
Sure.
Okay, something is going wrong here.
You see the video button?
Yeah, hold on. You can see my screen, right?
Yep, I can see your screen,
yeah.
But cannot see your face yet.
You cannot see my face yet? Okay. You're not missing much, but never mind.
Okay.
Okay, I'm not sure what's going on here. Let's see.
If you really cannot turn on the video, maybe...
Wait, let me stop sharing first.
Okay,
sure. Sorry for that. Okay, so now you can see the video?
Yeah, I can see your face now. Okay.
Okay.
Yeah, please share your screen again.
Share my screen again, yeah. Share.
Yeah, all good.
Okay, start my video, that's done. Okay, just get my notes here. Yeah. Okay, thank you. So sorry for that, everybody. I hope you're all still awake. So first of all, let me thank SSIA for inviting us for this talk. I realize that we're a small company being Akana Technologies. We're a local SME, not as big as the guys like Siemens and AMS. So we're very humbled to give this talk here today. The talk is about opportunities for the semiconductor industry in the era of digitization. And again, I mean, as a small company, we are a semiconductor component designer. Specifically, we do RF. So when people talk to us about digitization, we typically get a little bit of goosebumps, right? So when I got invited for this talk, we started thinking, well, what can we talk about? What is it that Arcana does that could really talk about digitization, talk about 5G, and solve some of the issues that we are facing in the current time and age, right? So what Minister Tan said is actually quite correct. I mean, we're all in the semiconductor industry. We all know that the semiconductor industry is totally and entirely enabling what we are doing today. It's enabling life today. But how is it that it enables us? What is it that we do that enables the global economic recovery that can help us get past this COVID-19 kind of experience? I mean, COVID-19 has affected us tremendously, and I really hope that when you bring your sensor out as soon as possible, I have to go for a nasal swab tomorrow because I'm traveling to Taiwan and I really don't look forward to it. So I wish your solution was out there already. But again, I mean, about 1 year ago, I was at the SSIA Industry Summit talking about the biggest challenges for 5G, new radio, what we thought then would be the biggest challenges. I think, again, no secret that these challenges, well, they're still there, but they're not the biggest challenges that we are facing today when it comes to the world economy, right? That being said, I don't want this talk to be a little bit of gloom and doom here, but what I have seen over the past couple of months is despite this economic slowdown, we have not seen that much impact in the semiconductor industry compared to other industries. For sure, there has been an impact, but not as bad as most industries are out there, right? I also think being in Singapore, we've also been lucky. I hope and I think most of us has been spared from personal tragedies if you would compare the situation to the US and to Europe. So if I look at it, the Singapore semiconductor industry, I think has been spared quite a bit from the worst case scenario, right? So I would like to make this talk a little bit positive around COVID-19, be forward looking and and help you explore how we think 5G and industries around it, around 5G, can play a role in this global economic recovery. So my talk will go through a few sections. I'll first start by giving you data, right? Because data is everything, and the data showing what is the current status of the semiconductor industry, not just in Singapore, but worldwide, and how has COVID-19 impacted it, just to give you an overview. I will then start telling you what 5G is, where 5G is today, and how COVID-19 has impacted 5G. Then I will talk to you about how 5G can enable new business models, right? And how these new business models can help with the global economic recovery, right? And then the last section will be more explicitly on infrastructure and challenges, because that's the area that Akana is in, right? And show you what these infrastructure needs are and why these infrastructure needs represent a very big opportunity, not just for semiconductor companies, but also for system integrators and new players on the market that are willing to look at infrastructure, small cells, and base stations for 5G wireless. Okay, enough said about the first slide. Let me go to the second slide. So this slide, you probably have seen it, right? It comes from Ericsson. During COVID-19, we've all experienced that, well, remote working apps have grown considerably. I mean, we all use Teams every day. We all use Zoom. We use things like Asana. So many tools, you know, it took us a long time to figure out which is the ones we have to use for what. But I think most people now are used to virtual meetings. They're used to virtual conferences and so on, right? So we have seen a very fast increase in these remote working apps. Also e-learning. I think learning today, most of the lectures, universities or also post-university have gone online, right? The classroom almost doesn't exist anymore. So we have seen again e-learning apps taking up a lot of applications over the past couple of months. Now, what this all means is as all these apps, right, require mobile data, right? It's not just being at home, but working remotely, right? So you need remote access anywhere you are because you need to work remotely, you need to study remotely and so on, right? And so this is not just something that has happened because of COVID-19. There was already a trend where more and more data was necessary. And we've just seen that because of COVID-19 and remote working and remote education, the whole need for more data and faster data transfer has increased tremendously, right? So it has sped up everything considerably, right? Sorry, okay. So if we now look at the COVID-19 impact on the global semiconductor industry, I mean, of course, there's been advantages. I mean, there's been advantages working from home for everybody, I guess, right? But we've also seen that in the semiconductor industry, work has not gone down, right? From my end, I can say, and I think most people in the semiconductor industry can say, there have been near-term impacts, right, considerably in terms of the supply chain because of shutdowns and costs. Also, market demand, consumer behavior has slowed down, which has affected the introduction actually of 5G mobile phones. Also, workforce, stay-at-home orders, quarantines, you know, all of this has really affected the business. But despite all that, right, the global revenue forecast for semiconductors has only slipped by 1%, or is only minus 1%, right, compared to minus 12% last year, right? So pre-COVID-19, people actually expected 2020 to have a plus 12% growth, right? COVID-19 has dropped that to minus 1%. But the question, of course, is, I mean, compared to other industries, this does not seem to represent that much. And so the question is, why is that? Why have we not been affected a lot more than compared to other industries? And I think the answer has already been given several times. It's really the entire need for more data, the entire need for more bandwidth. So data centers and 5G infrastructures were two business areas that were already booming before the pandemic. And when the pandemic started, there was a little bit of a dip, but very fast it recovered because people started to realize that they needed this data to get through this, that the working from home, that the online education was going to become the new normal. So people started investing into infrastructure, and infrastructure needs the semiconductors, right? Also, the public perception of having this infrastructure as an essential utility is quite important. And so the planned ramp up of 5G remained highly visible and also remained a national priority for many countries, right? We've also seen that the demand for 5G infrastructure has been a catalyst for Asian factories. Just published last week, you know, electronics rebound will give lasting boost to Singapore exports, right? So these are the non-oil domestic export in electronics. You see from February onwards, there was already a kind of growth. There was a little bit of a collapse, but things are recovering right now again. And most of it is really caused by the infrastructure developments, also by the need for data servers and so on, right? So if we now look at the 5G situation today, right? What you see here is what has happened until 2020. And to be frank, most countries, already around 400 operators in 130 countries, right, have launched 5G already, are in trials, have got licenses, etc., etc. And about 100 of these operators effectively have running networks, right? So pre-COVID, 5G was already happening, right? Naturally, there's now been a slowdown in terms of ramp up, but the existing investment has spurred existing investments combined with COVID-19 and the demand for more bandwidth has actually increased the investments and the rollout of the 5G infrastructure as we see it today. Right. If we then zoom in on Asia Pac, because we are of course in Asia, we actually see that Asia Pac is a very, very important market. Why? Well, almost 60% of the population is in Asia Pacific, right? 60% of the worldwide population. China, of course, is a big part of that, but it's not just China. There is India, there is Southeast Asia as well, where 5G infrastructure is really already starting to be deployed. We see, for instance, in Singapore that by 2022, there's already demands that half of the coverage of Singapore should be half already, and by 2025 it should be full, right? By 2025, 34% of the mobile phone users will actually be using 5G. This rollout is already happening, right? The frequencies have been allocated already in Singapore, right? And Singapore has asked telcos to provide this full coverage 5G by 2025, right? So digitization has already been an important target, right? And it's now moving up the agenda for businesses and governments alike, with many accelerating their timelines simply because of COVID-19. Especially businesses in retail, transport, logistics, manufacturing, and healthcare are looking to increase their investment in digital transformation to keep up with the impact of the pandemic and build a stronger position for the future. Okay, so if you now look at the 5G subscriptions in terms of a global outlook, this graph is quite bullish. This graph is published again by Ericsson and GSA. It's from May 2020, which is actually post-COVID. So it's already been adjusted post-COVID. What was seen in worldwide scene is that there was a minus 10% to plus 20% change in mobile data traffic. Why from minus to plus is because, well, in the city centers, there was less because people were working from home, but then of course people in the urban areas working from there were using more mobile data. Overall, they saw that mobile data traffic grew by 14%. So again, showing that there is more need for data, and we all know that. 83% of the smartphone users claim that ICT helped them a lot to cope, right? Even when they're at home, right? I remember in the very beginning, I have good bandwidth at home, but once everybody started working from home in a condominium, the Wi-Fi was not that great anymore, the bandwidth was not that great anymore, but every now and then I could use my mobile phone to save myself in a meeting and connect again, right? So yes, so we do see that 5G subscription from a global outlook will continue to increase. So you see from 2020 to 2021 and moving forward, right? You will see that 5G continues to grow and starts slowly to replace the 4G networks as well, right? So what is the impacts? I mean, of course, we can say 5G continues to grow, but naturally COVID has had an impact, right? There has been an impact. Why? For a number of reasons. First of all, the handsets have slowed down a bit, right? There's been supply chain disruptions, right? Shutdown of facilities, shutdown of manufacturing, shutdown of testing, and so on. And this has created a delay in the market. I mean, even the new iPhone is now shipping out later, right? We've also seen that in terms of specifications for the next 5G, right? There's been a delay of 3 to 4 months. Right, again, caused by COVID, by researchers not being able to attend their labs and the meetings and so on. So R&D has slowed down a little bit. But what we see from this slide is that even though there is a dip in about 20% in 2020 in terms of connections. We see that slowly by 2025, it is anticipated that it will recover. So there is a bit of a slump and there will be a bit of a slowdown, but 5G will recover and will get to the point where we would have been before COVID-19. So what does that mean for infrastructure? Again, here from markets and markets analysis, is that you do see that post-COVID-19 and pre-COVID-19, there is a difference in total investment in the infrastructure market. But what you do see is that the growth is the same, right? So over the period of time, we are a bit 2 years delayed with the entire infrastructure rollout, right? But that being said, we do see that the growth rate continues, which is actually a positive factor. Okay, so talking about the first part of the talk was more to show you, well, what is the status of the semiconductor industry in the pre and post-COVID area? How does that affect 5G in terms of rollout, in terms of people adopting 5G, and in terms of the infrastructure market, right? What I would like to talk about next is to really look more into the new business models. And people have talked about this many, many times, so I'll go through this quite quickly. But looking at new business models around 5G that will show that not only is fast data needed, but other applications for 5G are needed, which will drive the infrastructure growth and again will drive the semiconductor industry delivering solutions for this infrastructure growth, right? I think this picture you've all seen before. 1G, 2G was all about voice. 3G, 4G, 5G is all about data, right? Where 3G was simple mobile broadband, really pushed by the iPhone. 4G was really about mobile video, right? We wanted to see video on the phone. We wanted higher bandwidths to do video calls as well, right? And 5G, well, people are saying, why do we need this extremely high bandwidth? Why do we need to download a high definition video in 1 second? We don't need all that. But thinking about 5G as just the next generation high bandwidth is actually a bit wrong, right? We need to think about it as the enabler of really new cases. And it's the first time that an XG technology has been defined not just around specs for bandwidth, but has been defined about 3 core applications, right? One is enhanced mobile broadband, right? What are the specs that we need to allow enhanced mobile broadband to happen, right? The other one is ultra high reliability and low latency networks for mission critical control. What are the specs that we need for that, right? And then massive connectivity. We want to connect everything everywhere, right? We want to do massive IoT. What are the specs that we need for that? So for the first time, 5G was not just here are now the specs, now figure out what to do with it. No, 5G had the demands on this is what we want to do with 5G, now figure out what the specs are. And so that is the big difference with the previous types, right? So thinking about enhanced mobile broadband, what are we trying to do here? Yes, of course, we're trying to drive more mobile data. That's the first part, right? There are 2 key facets of this enhanced mobile broadband, right? First is extending cellular coverage, meaning we have coverage everywhere and anywhere and at a very high bandwidth, high data rate. The second one is to improve the capacity so we can handle more devices, more users, specifically in localized areas, right? These improvements in a network can allow more efficient data transmission, giving you lower cost per bit for data transmission, and that's going to be an important driver for increased use of broadband applications and mobile networks, right? Then massive Internet of Things, right? Massive IoT, I mean, IoT, everybody knows. IoT has been in implementation for the past 5, maybe even 10 years, right? Using even 3G, 4G, etc. What we're talking about now is really 5G enabling the scaling of IoT, meaning having IoT anywhere and everywhere, right? So initially 5G will build on early investments in all the traditional machine-to-machine interfaces and IoT applications already developed, right? It will enable significant increases in economies of scale that will drive adoption and also utilization across all the sectors, right? 5G, we know, has improved low power requirements, ability to operate in licensed and also unlicensed spectrum. Unlicensed spectrum is very important for private networks, right? Has the ability to provide deeper and more flexible coverage and drive significantly lower cost within massive IoT settings, okay? Mission critical services is the first time that we can allow this to happen in applications. We all know about the autonomous driving. I will be looking at some surgery, remote surgery as a use case later down the line as well. So not going into too many use case examples, but what we see is we have the 3 pillars, right? And giving you a few examples. Enhanced mobile broadband is about indoor wireless broadband coverage, outdoor wireless broadband, fixed wireless broadband, uh, relates to training, education, augmented and virtual reality, extended mobile computing, etc., etc. Massive Internet of Things. We all know smart agriculture, smart city, energy monitoring, and so on. Right, plenty of applications we've been discussing before, and mission critical services. Well, typically we talk about drones, cars, industrial automation, remote patient monitoring, and also smart grid type applications. Right. Just very quickly, 3 use case examples, which are not very often given, but one of them is smart grid, very important in terms of making our power consumption more efficient, right? And also making the world a little bit greener as much as we can, right? So 5G allows for network slicing. Because of this network slicing, you can allocate different network functions to different network slices, have different server level agreements, and as such, you can actually make your power grid much more efficient and much more cost effective. Cloud gaming is the next big thing. I think we have seen it even more because of COVID-19. I don't know anybody, any of my friends that right now does not have a gaming console since COVID-19. Everybody bought one, including me. I used it only a few times, but never mind. And so we see that this whole cloud, this whole gaming is actually moving into the cloud, right? Where all the computing and all the algorithms, etc., are running in the cloud, and people are just using a console handheld, and they're streaming all the data to do multiplayer games. And it's a very big thing. It's almost in the news every day. And then in terms of mission critical, we always talk about cars, but especially in the times of things like COVID, etc. You know, remote surgery is becoming increasingly important, right? And we've been talking about remote surgery for the past, I think, 20 years. I remember 25 years ago, I read one of the first papers about it. The tools are there, but what about the connection? How do you make this life critical in a sense, right? So that's 5G surgery. And enabling Industry 4.0 is actually a slide that, well, it's an application that deserves a slide of its own, right? So important here, right, is that we see that in Industry 4.0, which really means, well, we have private networks, or we link everything in our factory up together, right, to improve the logistics, to improve the productivity, to improve the efficiency, to know our inventory. So everything and everywhere gets monitored, right? That's what Industry 4.0 is all about. And we can do this, well, we can use this by using public networks, but more and more do we see these private networks being set up. And these private networks many times are in unlicensed frequency bands. So it becomes much cheaper, right? You can do it at a slower scale just for your factory, and you don't have to bid for the license, right? You also don't have to pay for the data, right? Because it's your own little private network. And that's where we see that over the next years, about 25% of the 5G infrastructure market will actually lie within small cells for private networks in unlicensed frequency bands. And surprisingly enough, people are predicting that this 25% of the market will be taken up by mostly new players. So we see that for new players in this market for infrastructure, whether it's semiconductors, system integrators, and so on, there is a really, really good opportunity to get into this market and play amongst the bigger boys as such, right? What will that enable? Just to give you numbers, okay, 13.2 trillion in global sales in 2035. The most important thing which I would like to highlight in this slide is that you see that 5G, all industry sectors, right, and the 3 silos are about the same size. So it's not just about the data. It's not about the massive bandwidth anymore. It's also not just about massive Internet of Things. And it's also not just about mission critical systems. The 3 of them are expected to contribute the same amount to global growth and to the global industry, which I think is quite important to note, right? So what does all this mean for deployments by region? What does this mean for infrastructure? So when we talk about infrastructure, we talk about base stations, right? The things that transmit that you see everywhere, big or small. And we see that the majority of the new sectors, if you look at the graph on the right-hand side, the blue one is Asia Pacific. And then all the small little things are the rest of the world. So we're in the right place, right? This is where the biggest deployment of 5G will happen. And it's not just because of China, right? There is China, there is India, there is Southeast Asia. There's a lot of opportunities for this infrastructure network to be deployed. right? China, of course, is quite big, but like we say, sometimes China belongs to China, right? We want to develop infrastructure solutions. It's very difficult to get into China, right? We typically have ZTE, there is Huawei, right? But again, infrastructure in China will be for the Chinese players. So just very quickly, because I think I might be running out of time, right? So there is diversity in—
No hurry, Glenn, you can speak
yeah.
at your own pace. Yeah, you still have time.
Oh, I still have time. Okay.
Yeah.
Okay, so fine. Good. So when we think about these new sectors, right? New sectors really means new base stations. And when we talk about 5G, we see that 5G, of course, will have to coexist with 4G for quite a while. And what we mean by coexistence is really that, for instance, you use a low frequency 4G signal to do the control and the functions and the handover, right? And then you use the 5G signal to really have the high bandwidth kind of applications. And so we see that this deployment is the preferred one in most countries, except for China, where in China they say we go for a standalone network straight away, but never mind. And so when we then look at the whole typical types of base stations, right, the challenge is you get multiple types, right? So 4G LTE, you get big base stations, the big macro things that you see on the roofs and where not, right? Then we're talking about sub-6 GHz 5G, which is already going into the small cell kind of area, but could be macro cells as well, right? And we have 5G millimeter wave, which not only has macro cells, the bigger ones that will go up to a few hundred meters, but they go into small cells, which go even at a smaller range, maybe 50 to 100 meters, and then repeater cells to get into the houses. So one of the challenges in all this base station infrastructure is that you need different technologies for different kind of applications, like macro cells, high power. You're talking about gallium nitride on silicon carbide, right? Small cells, well, you know, probably a combination of things, right? Where you start integrating some silicon for beamforming and processing together with maybe some gallium arsenide for NAND. And then when it comes to repeater, well, maybe your repeater can only cost $1. You really need silicon solutions to make that happen. So 4G and 5G base stations for new sectors, what I want to highlight here is that really for new players in this market and for smaller players in this market, really, there is a huge opportunity in small cells, right? You see for sub-6 GHz small cell, the growth of that is the highest. And this is primarily caused actually by private networks. Again, private networks where people see new players playing a major role there, right? The millimeter wave small cells, you don't see it in this figure, but from 2024 onwards, it's actually estimated that the millimeter wave small cells and millimeter wave 5G will start taking over from sub-6 GHz 5G, right? So by the time of, I think it's 2027, 28, you will see that millimeter wave and sub-6 GHz will have about the same implementation on a worldwide scale, right? Good. So what are the challenges? Well, many challenges, right? For 5G sub-6 GHz, some challenges, well, I can read them all, but most of you people will know. Of course, we need low power consumption, right? We need lower costs. Spectral efficiency is really important because sub-6 GHz, everything is so crowded already, which is why we need millimeter wave. But millimeter wave is years ahead, and we need bandwidth today. So we need to do refarming of frequency bands. We need to be more spectrally efficient. We need new designs. We need high reliability. We need better cellular throughput and coverage. So many challenges still exist with 5G sub-6 GHz, which are being addressed today in parallel with all the challenges that we see on the millimeter wave side, right? Millimeter wave side, I gave a talk on this last year, so just one slide from that, but you do get a lot more attenuation, you get a lot more propagation loss, so you need new technologies like phased array type technologies, which has its own challenges, right? You need different trade-offs for semiconductor technologies. Why? Because you've got different types of base stations, from picocells to small cells to macro cells, right? And then of course, because you've got all these different phased arrays and multiple antenna technologies, you have to think about all the interconnects, right? How do you connect all the components to the antenna? How do you calibrate this, which is a huge headache actually, right? So all of that from a system point of view leads to semiconductor components, which gives you challenges of 5G, right? And of course, with challenges come opportunities, right? And that's what we're always excited about. So the challenges that the challenges for these devices, right, are you need to have a wide bandwidth. You need very high power efficiency, you need high linearity, design flexibility, trade-off of best process versus cost, you need high reliability, you need a small size, you need high density integration. I think in the semiconductor industry, we all know that people want everything, right? And of course, they don't want to pay a lot for it, right? So what do we do in Akana? Well, in Akana, we just do RF, right? We do the RF front ends for radar, SATCOM, and of course for 5G. This is mainly LNAs, amplifiers, power amplifiers, switches, both for small cells and for macro cells. That's for the sub-6 GHz. And so we're launching our products as a local, I wouldn't say startup anymore, but as a local company, I think we're one of the first fabless semiconductor suppliers in Singapore, homegrown, that is now pushing these products into the market. In terms of millimeter wave, this is where our R&D goes on, and where we have been lucky enough to be funded by ESG and NRF to develop the next generation 5G millimeter wave phase array systems. We are combining this with our R&D setup in Belgium, where we collaborate with IMEC to develop the next generation 5G, more specifically in silicon, SOI and silicon germanium. So this is to be ready by 2024, and is the next generation. So in a nutshell, as a company, because probably most of you have not heard about Akana before, except maybe at the talk next year, we are headquartered in Singapore. We really started about 3 years ago to start developing our own products to come into the markets. We do not include any US technology, which has had a lot of advantages for us moving forward. We have an R&D center in Belgium, currently about 10 people, which focuses on silicon CMOS technology and SOI. We also have about 25 people in Taiwan that do R&D, but mostly product engineering, test and assembly. And well, in Singapore, we're primarily focused on doing R&D in 3.5 gallium arsenide, gallium nitride technologies. Our head office is here, we're fully Singapore owned. Testing and packaging is done here. And of course, our sales and finance is here as well, right? So we're a supplier of MMIC components. And because I only had 2 slides, I was only allowed 2 slides to talk about Akana. I'll stop about Akana there. So in terms of conclusions, right? We see that for developing recovery, I mean, COVID-19 has had an uneven impact on the semiconductor markets, if you compare it to other markets, right? And we see that 5G will actually be a catalyst to drive new opportunities, new businesses with 5G communication infrastructure, I wouldn't say keeping the semiconductor industry afloat, but really giving the semiconductor industry a boost, right? So this was the topic of our talk, where we really say, look, there's all these applications, all this digitization that will happen. And the application to semiconductors will be, from a big point of view, also the infrastructure play. Let's not forget that. And the infrastructure play has to be built before the consumers fully adopt, right? So 5G infrastructure, to implement 5G, a massive amount of new hardware has to be deployed. And the Singaporean semiconductor industry needs to be agile and well-positioned to capture a slice of this opportunity in the years to come, right? So we see it's extremely important, especially in this day and age, to collaborate amongst our local ecosystem in Singapore, right? To develop these opportunities, to look into, can we develop some sort of a consortium where we develop small cells, right? Where we develop small cell solutions for private networks, because this is something we can do, right? To start competing with the likes of Nokia and Ericsson and ZTE is very, very difficult, because these are very vast networks. But to do local networks for Industry 4.0, we see a big opportunity there. And so we are trying to reach out to as many people as possible to see what can we do for small cells in private networks, combining RF solutions with existing FPGA solutions, with existing baseband solutions, and develop these kind of small cells for private networks. And so with that, it's an open invitation for collaboration, not just with local SMEs, but also with MNCs in Singapore and with the research institutes to form an alliance and move forward on this. So that's my talk. I'm sorry for going a little bit long, right? But I expected that. So anyway, if there's any questions, I'm happy to go back to some of the slides.
Thank you, Glenn. Thank you for the presentation, and the figures and updates on the 5G market are really impressive. So let's look into the questions. First one from YH from AI. What is your thoughts on the outlook for demand of data center in 2021? Do you see mmWave or Sub-6 as an engine of growth for 5G in 2021?
Specifically Sub-6. So we do see some implementations starting in millimeter wave, but it's still more on a trial basis. So sub-6 gigahertz is seeing the major drive at the moment. I mean, from, let's say, all the customers contacting us for RF solutions, about 95% of them ask for sub-6 gigahertz, right? So we do see that sub-6 will be the driving force initially moving forward.
Okay, so Terence from EDB asking, what is the competitive landscape like for Akana? How can the Singapore community win in this space?
That's a very good question. So I think it really depends what you do, right? So we thought about this for quite a while. If you think about competing in the digital space, right? Competing in 5G digital space and say we're going to develop the digital processor, the baseband, et cetera, you need a team of hundreds of people, right? It's very, very difficult to get in there. So you try to get into a specific niche market where you can have a play. And that's why, I mean, that's why we saw for RF, there is a play, right? Because different countries need different frequency bands, need different specialized solutions. Private networks need different specialized solutions. So we're looking where we think Singapore and its ecosystem can play a role is more in the niche markets, right? I don't think we can build a local company here that is going to compete with Qualcomm or Broadcom, right? Or the NXPs of the world, right? But we can build niche solutions within Singapore that can not only help the local industry, but they can have implementation in Southeast Asia, right? Because where is the manufacturing hub worldwide, right? It's moving towards Asia. Maybe now because of COVID-19, there may be some change and it might go back to the US and to Europe, but we do see that there are opportunities to look into the niche applications within Singapore. Do we have competition? I can tell you, yes. We have competition. Our biggest competitors are Skyworks. Our biggest competitors are Qorvo, the big MNCs, right? And this is something that is, of course, very difficult for a local company to compete with, right? Because also from an economic development, I mean, from an EDB point of view, where semiconductors falls under EDB, right? But Akana being a local company as an SME falls under ESG, which has a different level of funding for R&D. And although we have been very well supported so far by ESG, there is still a wide difference in what we can do to compete. But still we manage, right?
Good. Okay, next question. Really nice to see a homegrown semiconductor company working on 5G RFFE. What's your thoughts on how Akana can compete or collaborate with big players such as Broadcom, Qorvo, Skyworks, Murata, to name a few?
Okay, so good question. Huh? So when we talk about Broadcom, I mean Broadcom will mainly be on the Qualcomm on the handset side, right? The end user equipment. Qorvo, Skyworks have got a big play naturally in infrastructure. So let me just talk about these two. Now, typically the Qorvos and the Skyworks, they're tier one players. They deliver to tier one customers, right? Tier one customers, we all know them. They're ZTE, used to be Huawei. There's Samsung, there's Nokia, there's Ericsson, right? So those are the big five. Now, there's a lot of other players, tier two and tier three, that are in the infrastructure market, right? Which do not get, they do not get priority when it comes to supply, right? So the newest components, the most efficient components will always go to the tier ones first, and then tier two and tier three follow. So what our strategy is as a smaller company, we have the advantage that we can follow very fast with a solution that tier ones introduce, right? We can follow them very fast because we are a small company, right? We see a new chip coming out, within 6 months, we can have the same chip in the market, which in semiconductors is very fast. And so because of that, we can deliver to tier two and tier threes, right? What the tier one semiconductor suppliers are delivering to the tier one operators already, right? And that's how we compete. So for us, it's of course difficult. We will not be able to sell initially to the Nokias and the Ericssons, but there's plenty of tier two, tier three that can give us valid business, that can get us into the market. And especially now that we're looking at 5G, the small cell, the private networks, and the infrastructure play, it's really an important play for new players to come in and build up their expertise. And who knows, I mean, if Singapore or places like Taiwan, where there's already a lot of integration capabilities, they could start thinking about somebody who could really be a big player in the small cell networks for 5G, whether that's from sub-6 to millimeter wave part. Because We have the semiconductors, we've got the integration expertise, we've got the software, and we've got the industry, the manufacturing industry that really needs this 5G private network deployment.
Okay. Next question, what are your top challenges in capturing the Sub-6 5G market, and what areas of collaboration is Akana prioritizing?
Okay, I do know the kind of top challenges in capturing Sub-6. Okay, the top challenges, gosh, I mean, if you're a starting company in semiconductor, one of the top challenges is really the access to the market, right? And the price point, because do you have the credibility? You know, you're a starting company and you go and talk to big guys or even tier twos, and people know how much it costs to just develop one semiconductor solution. You're talking about $5–10 million. So how do you, as a small company, convince people that you've got the capability to doing this? That's one. And then secondly, because initially your volumes are low, how do you convince the customer you can give the right price point, right? So the biggest challenges for us have been to build relationships with the customers, show our credibility, what we could do, that we can deliver, and then also showing to them that we can deliver it at the right cost, right? Areas of collaboration that we are prioritizing, this is very much for us at the moment related to research in the millimeter wave side, which we're doing with A-Star, which we're doing with our Belgian colleagues. So this is very important. When it comes to commercialization right now, it's really working with system integration houses that can use our RF solutions and combine these with other baseband players in the market, right? Can develop reference designs with that. So that's what we are really looking at in terms of collaboration at the moment.
Okay, I think we can answer two more questions from here. What's your opinion on US and China competition on 5G development? Where are they now and which country is likely to win, or is it really matter?
I don't think it really matters who is going to win, right? I think, I mean, to be frank, I think China is already winning, right? It's one of the reasons I mean, forgive me for thinking that, but my view on the trade war is that a lot of it is also being pushed with the fact that China is ahead in 5G, right? They have been ahead for quite a while. Now, whether they got there in a legitimate way, I don't know, right? And whether the actions right now against China are justified, I also don't know. There's a lot of politics involved there. But I do think, I mean, they did have a head start. What's happening now is they're being slowed down, but we see tremendous investments going on in China right now to make China fully independent from the US semiconductor supply, right? And that's a very, very important message that I think in the long term, the US semiconductor industry might get hurt simply because of that, right? Who's gonna win? I think we're gonna end up with mobile phones that will have different standards again, right? We'll have a phone for the US, we'll have a phone for China, right? And this may happen. Gosh, it's a very loaded question. And I think probably best maybe if there would be a dinner right now, then we could all have a beer and talk about China, US, right?
Yeah, we always do.
We have seen from Akana's point of view being in Singapore, not using US technology, for this to be an opportunity for us because we are neutral. And even operators that are not in China are getting a little bit, you know, edgy with the, how do you say, the shiftiness of US regulations, right? A lot of these things are strategic goods, and a lot of these things now you need export control from the US, which slows things down. And so people are trying to look at a secondary supply chain for the semiconductors that does not just come from the US and does not just come from China. And I think there, as a Singapore company, we again have a big advantage being neutral and having the R&D capability to actually develop this.
True. So let us go to the last question. For the unanswered question, we will get back to them on the LinkedIn page. Can you briefly talk about the processing power and edge compute modules for 5G?
Oh, I would love to, but I don't think I can. You see, when I said initially in my talk, we are RF people, right? And so when people talk about digital stuff, we get goosebumps, right? So I'm not an expert at all when it comes to edge computing and processing power for that. So we're really on the RF side, the core RF side. Yeah.
Okay. Thank you. Thank you, Glenn.
Thank you.
Thanks for your presentation and all the answers to our Q&A. For those unanswered questions, once again, we will get back to Glenn, get the answers and post it on our LinkedIn group. Okay. So please do join us.
Thank you,
Glenn. Thank you. Okay,